Hello, this is Max Carduner, and this is the walkthrough of my code. First, you asked us to modify the evaluate function with the updated metrics. Correct is still the same. Accuracy was correct over the sample size. And then I rounded everything to 4. And then for the next metrics, you needed it to be in the format where not the argmax for the largest neuron in the outer activation layer, but you needed the actual activation layer, the outer one, and the Y, which is also in the same vector format, the same dimensions. So MSE, simple application of your code that you provided times the 1 over length of the test results, and then cross entropy, same thing, and then log likelihood we had to do it ourselves, and then for this one, you said to make it that the argmax position for the y vector should be the one you take the log of in the outer activation layer. So that's what I did here, and I cycled through all of that, and then divided it by the amount in the test results with a -1 there, because log is a negative number, it needs to be positive. This one is a -1 because there's the negative is here, -y. Okay, moving on to the next function, the SGD function where we actually implement it. You'll see how it prints out in a second, so I'm not going to go through all that. But you'll see that the train metrics is greater than self-term percent here for, which is the completeness or the accuracy, so that it breaks, as you can set that parameter, and then return as a list of lists. Which you'll also see in a second. Mainly thing I want to show you in here, though, is activations. I initialize it as a numpy empty array with the dimensions of what each of the sizes are in the self.sizes variable in the class. And then I initiated that by replacing the 0th layer, the first index of the list, with just the inputs, because that's what X is. And then we cycled through. So then I initiated a counter incremented by 1 because 0 is already for activations, and then added, that see it as a new activation layer for each of the activations, and it's just replacing the size and the memory like you mentioned in class. So that's how that's working. Nothing else was changed. Okay, let's go to the application code. So this is all the code you provided. You can see it's working properly here. All these numbers tie out with yours. I just rounded them to 4 decimal places. Here you'll see that the results for the second list is missing because that's where the test set should be, and you'll see it kind of lines up. And then here there's no test set result. It looks a little different in yours because mine is rounded, and then there's no test set for the epoch because there's no test set passed through, so the code worked properly. And then for this one, testing the term percent at 0.6, you see it ends after it gets to 0.667. And then doing the same thing as above, but with the 427.3 network. Works as it's supposed to, ties out to your metrics up there. And then as you get down here, the result set still is empty for the test set because no test set was applied. And then here, we test the term percent, set it to 0.6, and you see it ends at 0.66 here after epoch 33, which ties up to your code. And then I did some visualizations. I talk more about that in the other document, but you can see it here. Essentially, I looked at different mean square errors for different eta values on the IRIS 427.3 network at each epoch. Thank you.